Okay, so on this one, we're going to find the distance from a line to a point. What's the straightest distance from me to Chris? Walk straight line, but what's the problem? Am I going to walk right through Jesus?
You could.
I could. Okay, if I were a bird, I could fly over. Same thing here. When you're trying to find the distance from a point to a line, you have to have a segment that's perpendicular. So what they're giving you is a point and a line, and what you need to create is the line that's perpendicular to this line right here. So your perpendicular, your 90 degrees is right at the line, and it's going to go through that other point. So right here, looking at this first example, it wants to go from E to line AF. Now, the problem with your visual here is AF is a line, and a line keeps going, correct? So this line right here is extended. What do I need to find? What do I need to create?
Right angle.
A right angle. So what would I do to this picture to make a right angle?
Just drop it straight down, man.
Good. Just drop straight down. This is my 90 degrees. That's good. I would need to know how far is this distance. That's going to be the shortest distance from that point to the line. Wait a minute, Miss Ramsey. No, it's not. It's from here to here. Well, wait a minute. What shape do I have right here?
That's a triangle.
A triangle. What is this side right here called?
That's a side.
Isn't that my hypotenuse?
Side here.
Which would be my longest side. Which tells me that this side right here would be shorter because this one right here is my hypotenuse, which is my C, which is my longest, right? Okay, so I want you to look at 1 through 4, and I want you to draw the shortest distance from the point they give you to the line. Okay, so if I'm going from C to AB, how many of you drew that line right there?
I did it.
From D to AB, how many of you drew this line right here?
Ah, win.
Good. From T to RS, the line should have been right here to make 90 degrees.
I win.
And then from here, from S to PQ, and make 90 degrees.
Win.
Easy stuff?
Yes.
They have to be 90 degrees. They have to be perpendicular. Okay, so now let's apply that information. Okay, now let's actually put it into practice here real quick. Now they want me to find the distance. Remember, I have a distance formula. X2 minus x1 squared plus y2 minus y1 squared. Or we have done Pythagorean theorem before. Correct? So I am trying to find the distance from point P, which is right here, to line Q. Are they talking about from here to there?
Maybe.
No, they're saying from point P to line Q, which is this whole thing. So what am I going to do to get the distance?
It's going to drop it straight down, man.
I'm going to drop the perpendicular, which is right here. So how big is this green line?
3.
3. Very good. I can just count because I have a vertical line. Okay, do number 6. Okay, again, it is not from point A to P. P is not a point. P is a line, which means that I'm going to go straight from here perpendicular to that line.
It's 7.
And it's what?
7.
It's 7. Very good. Okay, flip the paper over. Here's the deal. Now I don't have horizontal or vertical lines. I'm still going from a point to the line. And what do I know that the lines have to be? 90 degrees. So how do I make something 90 degrees from this? Hold on, let's finish this one. How do I make one 90 degrees? I find the slope, which is going to be up 3 and over 1. I want it to be perpendicular, so I'm thinking about or. So that's going to be a negative 1/3. And I'm going to start at the point. I'm going to go down 1 and over 3. Right? Now I can do Pythagorean theorem. 1 squared plus 3 squared. That's 1 plus 9. Yes, sit down, please. Okay.
I'm hungry.
And then I'm going to take the square root of that. So the distance from C to the line is the square root of 10. Are we okay? Okay, so then again, if I'm going to find the distance from C to line P, from C to line P right here, remember, I'm not going from C to P. I want to find the perpendicular. So the first thing I need to do is to find the slope. What is the slope of this line? Well, it's a negative slope, and my pretty points are here and here, so it's down 1 over 1, so negative 1 over 1. But we just talked about, I want to find the perpendicular slope, which means instead of being a negative, it's going to become a positive, and I'm going to flip those numbers, which is still 1 over 1. So from this point, I'm going to go up 1 over 1, up 1 over 1, until it reaches. So this is my line that's perpendicular, and it wants to know what is the distance from point C to the line. So here I can make that right triangle and do Pythagorean theorem, which is 2 squared plus 2 squared equals C squared, which would be 4 plus 4 equals C squared, which would be 8. Then I have to take the square root of that. Or, remember, I could go back to using the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. And the 2 points I want to use is this one, which is 1, 2. And the other point is this one here, which is negative 1, 0. So if I come back in and I want to plug it in, here's my x, here's my y, here's my x, here's my y. This is point 1, this is point 2. So my x2 would be negative 1 minus 1 squared. That would be negative 2 squared, which would be 4. And then right here, my y2 would be 0 minus 2 squared, which would give me negative 2 squared, which again would be 4. And then I'm going to add those together, which would give me the 8. And I'm going to bring down the house to square root it. So either way, I don't care which way you work. Same thing, problem number 8. Find the distance from C to this line. That means I first have to find the slope of the line. It's a negative slope from point to point, so it's negative 1 over 2. Then I need to find the perpendicular, which means I need to do the opposite reciprocal, which would be a positive 2 over 1. So from this point, I'm going to go up 2 and over 1, up 2 and over 1. That means this line right here would make it perpendicular. And then I want to know the distance from C to the line. Make that right triangle, or I can do the distance formula. This side is 2, this side is 1, so it's 1 squared plus 2 squared. 1 plus 4, which gives me a 5. So it would be the square root of 5.